Hello everyone, today we are going to give a demo video of our big data analysis project, the real-time human activity recognition. So as you can see in the screen, that our project is basically doing a human activity recognition on real time, and we detect the accelerometer's data on an Android phone and then pass the data to a web server and do a machine learning analysis on the web server. Then we will display the results in real time on a web page. So this is our frameworks. Can be divided into three parts. First part is the Android application. And the second one is the Amazon EC2 Linux server, which store the PHP script and also the include the MySQL database. And the third part is the Ubuntu server. There we have the machine learning program along with the web server. So yes, this is the basic framework of our project. When we have a user interface to control the program on the Android application and to send the data to the MySQL database through some PHP script. And also the machine learning project will also use the PHP script to get the sensor data from the database and do some analysis and return the our recognition results to the database. Then the web server will get the results also from the database and display it on the web page. So this is basically our UI. It's very simple. The first screen is the login screen. We don't have a password yet, so you can just enter your username and log in. So the second one is the main screen. We have two modes. One is training mode and one is testing mode. So the training mode is the mode we use for collect the training data for our machine learning model. So we have 6 activities to detect, and you can select the activity on the menu, and then when you start the training mode, it will record the accelerometer data and store it into a local file. And then the testing mode. Testing mode is our main functionality mode. So it has 2 underlying services. One is called the record service and one is called the activity recognition service. So the first one, the record service, is to record the 3-axis accelerometer data and pass the data to the database through PHP. And the second one is actually Google's API of activity recognition. So it will connect to Google's server and return the Google's results, also save it into our database. So we will use these two to compare our result to Google's results. So this is our database. We use a MySQL database which is built on the Amazon RDS server. So it has 3 tables. The first table is to store the 3-axis accelerometer data. So it has username and XYZ accelerations. So it will store all the user's information in one table. So when the machine learning model want to get the data, it will get specific users' data and select by the username. And the second table is the table we use to store Google's recognition result. So it has username and Google's result. The Android phone will read into it, and the machine learning model reads from it. And third table is the our own recognition result along with Google's results. So basically, the machine learning program will write our own recognition result into it along with Google's results, so then the web server can get the result it want to display on the web page from it. Okay, so Junkai will introduce the remaining part of our project.
So, I finished the data collection first. So we collect the raw data from the application build our Android smartphone as mentioned before. So our sample frequency is in 50 Hz. We divided the data in 1 second segment and generated features that were based on the 50 readings contained within each 1 second segment. So we can consider many factors when we select such sampling frequency. It can't be too high because the limited processing speed. We need to write all the data into the web server database. So we cannot collect many data because we cannot finish it within a limited time. So our segment size cannot be too small because we should ensure that enough data can represent the real-time activity. On the other hand, it cannot be too large because the real-time monitor requirement. And each reading contains 3 axes x, y, z of the accelerometer. So it is what the raw data likes. It contains the x, y, z and its label. So in the next step, what we do is to select key features that can fully represent the activities. So after based some papers and our efforts, we extract 49 dimension features which have satisfied accuracy and excellent robustness to the data. It is the average standard deviation, max value, mean value, difference between each readings, band distribution, and the average result and acceleration. It really represents the time domain data, and we select them for our later on machine learning algorithm. So we collect the raw data by ourselves using the Android smartphone. In the table, you can see that we have about 4,600 raw data, and we split them into 17% training set and 30% testing set. And we mainly use the 3 machine learning algorithms, naive Bayes, KN, and SVM to build our collision model. So the accuracy of each algorithm can be found in the chart. We can see that SVM have the most accuracy. So that's why we use it as our machine learning algorithm to build our model. It is the confusion matrix of SVM. We can see that we can exactly recognize the activity like sitting, standing, running, walking, but because the upstairs and the downstairs have some similarities, so our models can make some mistakes, but the overall performance is satisfied. So the next thing we do is to build a web page which can real-time show our results. In the front end, we use HTML, CSS, and JavaScript with Chenze 2 template, and in the backend server, we use Python with Flask framework based on the AWS Ubuntu server with virtual environment. So it is exactly what we build our remote web server. So we firstly should log in our web service by using SSH, and we can set the virtual environment on remote server. So the server program was written by Python, and then we can upload all valid files to the remote server. So the key functionalities of our web server is given below. We can handle requests from default port and send related files to users, and we can retrieve and process data from database and send the parameters to users. So in the framework, we help to add user authentication process to Android application and website, and we hopefully to dynamically display geographical information on the website with Google Map API. And the next thing, we can do the real-time demo. So you can see, we can first, we have log in our web server, and firstly we can log in, and in the web page you can see it is the dashboard of our web server. There is nothing initially. So the second thing we do is to initialize our Python algorithm. So it is done. So then we can log in on our application based on Android phone. Okay, it's just log in, and we push the button start. So you can see the web page, there's something show up, and you can see our testers. Yeah, it's just sit. So you can see it's it's just sit, and now he's standing, and we can see our web page. Because there are transitions between two states, so there are some errors, but when it becomes stable, it shows that errands is just standing. So now we will let errands to have a walk and maybe running. It's just a walk. So you can see he's just walking. Okay, and you can see that Google regulation results showed he's just on foot. Both of our predictions are right. So we can also support multi-users, and that means many users can use their cell phones to achieve such activities. So that's all we want to present.